Just to reintroduce myself, I'm Hans O'Sullivan, CEO and co-founder of StorMagic. I'm here with my other co-founder, Chris Ferry, who's the CTO of our company. And what I'd like to do in this presentation is to actually go into some of the use cases on where our technology is being used today and why some of these customers went for our technology. There's some of these customers you're going to guess who they actually are, but we're actually prohibited from mentioning their name. I would ask that if you do guess, that you keep it off the record, please. So, the typical sort of mission-critical operations that are using our technology today. Retail is by far our biggest vertical, and it's typical once you start to close a couple of very big accounts in a vertical, word spreads. People have seen that other companies have already taken that plunge and used your technology and it's working, and it makes it a lot easier. Our first big successes were within retail here in the US and also in Europe as well. In fact, Italy is a very good market for us. A lot in our pipeline in Italy as well. Government, diplomatic communications platforms. One of the European governments is actually using us in all of their consulates and embassies worldwide. There's a common thread that runs through here, which is applications that must continue running, that are remote and that don't have local IT. For whatever reason, they don't have local IT. So in the case of diplomatic systems, you can kind of understand why they don't have local IT. In the case of battlefield communication systems, you can understand why they don't have local IT. And that is the third vertical that we mentioned there, defense. I can mention the German army, and I use that as one of the case studies coming up. We actually also have some business within the US within defense. Manufacturing, here process control, there'd be typically companies with a lot of remote factories that are relatively small, that they need to ensure continue running. That's quite a good sector for us. Financial services, restaurant and hospitality is actually a growing new vertical from our point of view. Hotel chains that need to ensure high availability at the edge that's cost effective, typically don't have IT resources available there either. Transportation, energy production, I give an example on the energy production later on as well, and medical packs. So the first case study, this is our largest customer to date. We actually have much larger than this in our pipeline at the moment. It's a large, big box US retailer, over 2,000 locations throughout North America. It has, today it's running 2 servers per site with high availability. Yeah, you've guessed who it is. Before they came to us, they were virtualized, they were running 2 servers, they had a physical SAN, and I'll give you some of the statistics on what they were suffering as I go through these slides. Actually, as good as point as any, they were typically finding they were getting 100 SAN failures a year.
Well, that would suck.
It did.
Okay, just making sure.
Each SAN failure typically took 6 hours to recover from. Each hour cost the business $25,000. You do the math on that fairly quickly, and you'll see how much the business was losing because of SAN failures, because a SAN was a single point of failure. In some situations, if they totally lost the data, it could cost the business over $500,000 to recover, because they had to go out and do a complete restock take of that particular site. So the losses could in fact be a lot larger again. They wanted to go through a refresh of their technology. They went out to the market to see what alternatives they actually had to using a physical SAN. They came across the principle of using a virtual SAN, and they tested all of the virtual SAN technologies that were available in the market at that particular stage. Obviously they selected us in the end. And we will, as we go through the slides, show why they selected us versus our competitors. What they required, high availability. Important to them, they'd suffered over the previous 4 years by not having true high availability. They wanted to reduce the branch infrastructure. They wanted to be able to manage it from the center. They have one central location. They have, I think it's 6, it might be 7 vCenter implementations in the center that they manage all of their remote locations from. They see everything from those vCenters. They needed, the high availability needed to allow for a couple of days recovery time because it could take time for them to ship out a replacement server. They wanted to be able to reduce their cost of maintenance as well. So previously, if they had to do an upgrade or if they had to replace a server or whatever they had to do that after midnight when their stores were closed, which was very expensive because of having to pay overtime, having to have security letting the people in. With an implementation like ours, they now actually do their maintenance during the day because they can just shut down one of the servers, everything fails over to the other server, runs as normal, they can do whatever maintenance they want to do on a single server, fail back, everything can be done during normal business hours.
How many SAN failures a year did you say they were having?
100.
100 times 6 times 25,000. Somebody do that.
See, one of the things that happens is when they're replicating something over large numbers of sites, they need a SAN solution, but they'll go for the cheapest SAN solution they can get.
Okay.
And the cheapest one is not necessarily the most reliable. So we're not talking about enterprise grade SANs here. We're talking about, low cost sort of iSCSI arrays.
Yeah.
Now keep in mind 2 terabytes of storage. This is typical of these applications. 2 terabytes of storage. You're not going to go out and spend, $100,000 on a SAN in each of those locations.
Hopefully not.
You mentioned this is a 2-server solution. I get that, but how far hardware-wise, cluster-wise, can you go with this?
Chris?
There's no hard limits. The way the software's been designed, there's no hard limits in anything. It's really down to resources, and it will scale as per resources. We do synchronous mirroring between sort of pairs of servers,
right.
But you can have any number of mirrors. So, you could have 3 servers with a mirror A to B, B to C, and a mirror C to A, or whatever combination you want. And as you get more servers, you could have more mirrors. So we only do 2-way mirroring at the moment. We haven't seen a need for doing 3-way, but you can have as many 2-way mirrors in whatever combinations you want across as many servers as you want.
But they're always in pairs of nodes, so all data
No,
on
they're not
one...
pairs of nodes. They are the individual virtual disks are across a pair, but you could have one virtual disk between A and B, another virtual disk between B and C.
Mm-hmm. Okay. What have you tested scalability to in the lab then?
Number of nodes.
Yeah. Couldn't really answer that. I mean,
Because it's all pairwise distinct.
Because it's pairwise, there's not really anything.
They're really not combining multiple units.
No.
You're just combining, however many pairs you pair it up to within virtual disks. I don't know, if you're talking a real clustered system here per se.
No, it doesn't sound like it.
No. I mean, one of the things we are looking at, or are working on for future releases, being able to create clusters of systems and do a bit more automation of placement of data on those systems and so forth. Yeah. So there'll be some limits on that. But
would the limit in this case, based on what you just said, would we see limits based on basically overall bandwidth? Because at some point you're going to have.
And it depends on the workloads you're putting on it and so forth. Yeah, because it's because all the data is synchronously mirrored. Any data written to one side of the mirror has to be sent to the other side of the mirror.
And you're synchronized across the LAN. Is that the way it works? Yeah.
So typically it's across a local area network, sometimes a metropolitan network.
Yeah.
And typically I find in a lot of these applications that they're talking about 1 gig Ethernet as well.
Ouch.
But we can, if you've got a single 1 gig Ethernet connection, we can use it. If you've got a pair of 1 gigs, we can use it. If you've got 10 gigs, we can use it. We can use whatever network interfaces are made available to us, and we will scale to use whatever's there.
So going back to this customer, what he actually saved. Now I gave you some figures earlier on what the business was actually losing. This is not the same figures I'm actually giving here. So when he went out for tender, saying we want to have 2-server high availability. We want to see what can be done through hardware and what can be done using a virtual SAN solution. So the choices they came up with is, once more, put a physical SAN in there. That's going to add, obviously, significant cost. Or with a lot of the other virtual SAN solutions that are out there, you have to have a minimum of 3 nodes. And that's to solve the split brain situation that you're probably familiar with. And if not, we can talk about a bit later. Once you have to put that third server in there, you're adding 50% of cost. So fairly quickly you can see that they're saving 30% of cost on hardware, or 50%, whichever way you want to calculate it. OpEx, they actually saved a lot more than that. In fact, their calculation was, by going to a 2-server software SAN solution, that they saved between $500,000 to $1 million a year on power cost alone. So quite significant saving on OpEx. In testing the different solutions that were out there, they found that ours was the only 2-server solution that worked, that could actually met their needs, and hence chose our solution. From a performance point of view, we were able to at least meet, and in some cases beat, the performance of an external SAN. So we easily met their performance requirements. And part of the reason for that is because it's an active-active solution. You can read from both sides of the mirror at the exact same time. The only active-active solution there is in the market. And also because our stack was actually purpose-written and is optimized. So where others may end up getting similar performance, they do so requiring a hell of a lot more CPU or memory resources than we do to actually provide that level of performance.
So do you take advantage of PCIe flash or SSDs or anything like that? Or?
Sorry, what was that question?
Do you take advantage of PCIe flash?
So we can run on whatever storage is assigned to the VSA. So you can assign SSD storage and you'll get the benefits of SSD storage.
You don't necessarily try to optimize data across disk and SSDs?
So that is something we're working on. We've just released SSD write-back caching, so we can stage writes on SSDs. And we're working on read caching at the moment for a future release.
But it's actually quite interesting. The reasons that we're doing that is quite different to the reasons that other people are doing it in the solutions they have. The reasons we're doing it is because the amount of capacity that people have at the edge is extremely low. But to actually have 2 terabytes on a single spindle is likely to cause them I/O problems. So they don't need more than the capacity of a spindle, but they need the I/O performance of more than a spindle. So by putting SSD caching in there, we can actually help them to get the performance out of a much lower spindle count.
How are you licensed?
Most reads than writes, because I don't know how the counters work, but they have many different lines in the single check bill or whatever. So if you update a database from 20, 30 counters, it could be a problem.
So
which kind of workload do you see in there?
So it is actually quite typical. So you're talking about an 80-20% type split between read and writes is quite typically what we see. It can vary in the different verticals, but it's not actually that different a data pattern that you'd expect to see anywhere else.
Okay.
The write performance advantage is important to us because obviously with synchronous mirroring, you need to make sure that both sides of the mirror are written to and acknowledged at the same time. And that can have a hit on write performance, which is why we attacked the write caching first.
So what happens if you have a node that's taken down for maintenance or fails?
Okay, we'll deal with that a bit later. I've actually got a demo of that.
Okay.
Yep, we're going into quite detail on that. The benefit as well is total hardware independence. So this particular customer placed a contract with a server vendor for servers in all of these locations, but has now decided that actually it might be for a different server vendor for any replacement servers that it has going forward. And because of our software, they're now totally independent of the hardware vendor. They can decide to change server vendor even within a particular site. They can remove their existing server that's there and replace it with a totally different vendor. That capability Chris will go into in a bit more detail later as well. And they're now using us also in distribution centers where they have more servers as well as on the edge. Another case study, Eon Energy, and this I mentioned earlier, wind farms. This is the largest private investor-owned power and gas company. They have, it says 100 plus, I think it's actually about 140 sites now globally. And if you think of it, by definition, wind farms tend to be in remote hostile locations. So it's on top of a mountain, it's out in the middle of the ocean. There are places where you're not going to have IT capability. Yet at the same time, high availability is very important to them. Windmills should not stop turning. If there is no wind blowing, then typically they put a little bit of energy in to keep it moving very, very slowly, so you don't put too much pressure on the bearings. You need to know what's going on at all times within that particular wind farm. They use our technology to provide that high availability within all of those wind farms. They can monitor that. Actually, was very, very interested in meeting the quote here at the bottom, Uri Fisher. I remember meeting him a year or two ago, and he opened up his laptop and he said, look, you can see here. And he was able to show me 150 wind farms running globally and what each one of them was doing at that particular stage, and which one of them was generating energy, which one of them was causing problems. And it was quite fascinating to see, you know, how much manageability they can have from a single central location. From the point of view of downtime and IT, it typically takes 6 days to get someone out to that wind farm by boat or whatever to actually solve whatever the problem was. Their capacity, I can't even remember the figure, you're down into gigabytes, but they still had to have shared storage, they still had to have high availability on that. SafeKick, also in the energy sector. They're actually using this for oil rig monitoring software. Once more, these oil rigs do not have IT personnel on. If they actually lose their IT capabilities, they're monitoring what's going on within that rig, you're talking about hundreds of thousands of dollars or more in cost. In the effect on the business. High availability is very, very key to them. Simplicity is very key to them because they want to make sure it keeps running without too much complexity and without the requirement of that IT guy. They want the central management, but they want to make sure that if the central management breaks down, because obviously the communication links are not totally reliable, that the system continues running and they can continue monitoring what's actually going on in those locations. Savings to them, we've actually reduced their cost by 35%, but also reduced their licensing costs by 50% in employing our technology. German Army, battlefield communication systems. These could be in trucks like these that are actually in the middle of the battlefield to help control communications. Or as well as that, they actually drop some of these by parachutes as well. And I haven't met many IT guys that are willing to be dropped with that box into the middle of the battlefield. So very important to them that it actually continues running in the middle if there is a battle situation going on. It had to be military grade. It had to be very small, very light. In fact, they use solid-state drives because they didn't want any rotation drives within these systems as well. Easy to deploy and easy to manage. And once more, simple, centralized management.
Does it mean that you have an encryption feature to...
We don't do any encryption ourselves, no.
And do the military grade is reached on the hardware side? Because also on the software side, probably they need some encryption.
Yes, that's right. But remember, what we're providing is block storage. So you could use an encrypted file system, or you could use an encrypted disk drive in there. Okay. We don't care what's used, and that's typically the way people do it.
Which is good for us, because going through a lot of the certification-related encryption systems for military is expensive. So that's the end of that part of it. I'm roughly on time, I think. Running a little bit late. Any questions on some of those use cases?
Licensing of this, let's say, for a retail environment.
So what's it like? Yeah, so we actually license per capacity per site. So the typical site that would, as I said, the typical site is wants two servers and has 2 terabytes of storage. That is our entry-level pricing point. So our list price for that is $2,000. That covers both servers.
A 100 gig option or anything like that?
So what we do is we have a 2, 4, 8, 16 unlimited.
Terabytes.
Terabytes.
So
yeah.
after 16, you go unlimited?
Correct. Which is not our target market. So I think our largest capacity installations is about 200 terabytes, if I remember rightly. Typically, 99% of our customers are in the sort of 2 to 4 terabyte range.
So what's your 16 gig license run, just out of curiosity?
16 gig license, about $8,000.
Per terabyte, I mean. How much?
It's actually very, very simple. It's not exactly on, but it's very close to $500 a terabyte we charge.
And what about unlimited?
Unlimited, it would be $10,000.
Okay.
So more than 16 terabytes, you're unlimited, yeah?
Correct.
That's interesting.
part of what's important to our customers is to keep everything simple. The product is simple, it's easy to use, it's easy to install, it's easy to manage. Our pricing structure is simple, it's easy to understand, it's easy to use. And if you've got thousands of sites, it's got to be cost effective across those sites as well.
And in that sort of situation, then you could have you could have those 2 terabytes spread across 4 nodes, for instance, and it would be just the 2 terabyte cost of.
No. So typically, what it is, it's 2 terabytes per 2 server node. If you want to add a third server, right, and you're increasing the capacity further as well, then you'd add an extra $1,000. Half of that. We're basically pricing per server pair.
Okay.
And do you supply the server hardware, or can they just bring their own?
Whatever servers you want to use. You can use your existing hardware that you have. You can put in new hardware. I ran a hardware company, Eurologic, before. I never want to run one again.
Are you direct VAR? How do you sell?
How do I
Are
start?
you direct, or do you sell through VARs that could bundle things? Or
It actually depends on the customer. So the large customers, they're going to want to deal directly with the server vendors.
Right.
And we have strong relationships with the 4 big server vendors and partner with each of them. We've partnered with each of them in different deals. On the smaller deals, typically there's going to be a reseller involved. We have a high-level, well-trained sales force that will actually work with the partner or the reseller within the account. We do try and target directly ourselves those accounts so they're aware of what we're doing. So we could be brought in by a partner, we could be brought in by a reseller, or we may have found the business directly ourselves.